Hello and a warm welcome to the next video. In this lecture video, we will discuss something about turbulent flows. This is the most significant topic in any CFD simulation. And probably if you have ever worked with computational fluid dynamics solver such as Fluent, you must have probably used turbulence models as well or viscous models. And in this set of videos, let us try to understand what are they and what is the need of them and why are they developed. Now before directly jumping into that, let us understand what is a laminar flow and turbulent flow. So I just typed into Google turbulent flow and I got these images over here. Probably you must be really aware of the difference between the laminar flow and turbulent flow. The physical image over here describes a straight flow with straight arrows. So the flow in this case is streamlined and it is moving in a straight fashion. If you have a change in the design and because of the change in design, you have certain disturbances or fluctuations which are arising in the fluid flow, and these fluctuations are contributing to the turbulence in the flow. For that reason, this flow is now turbulent after crossing the design change. Similarly, you have a ball over here. The oncoming flow is laminar. After the impact of the flow on the surface of the ball, the flow downstream of the ball is a turbulent flow. The property of turbulent flow is like you have a lot of fluctuations. You can see the pattern of water past a boat, actually a water boat, and you can see the kind of fluctuations what the fluid is possessing. So these fluctuations are visible to us because this is water. We can see the water with our naked eye, but we cannot see the air which is present around us. So the air, when it interacts with certain surfaces like automobiles or any moving objects in the flying objects or moving objects in the air converts from laminar to turbulent as well, depending on the velocity, depending on the size and shape of the complete geometry. So there are many factors which are involved to convert the laminar flow into turbulent flow. Like you can see, this is a smoke. Initially it is a laminar, then it is getting transited into a turbulent flow. So this is about the turbulent flow, and this is a very significant topic in CFD. The point is, so far we have understood that we are utilizing the governing equations to solve the fluid flow, right? But if your fluid flow, if the project what we are dealing with, in that particular case, if we have a presence of turbulent flow, then there is a problem with those direct NS equations, that is Navier-Stokes equation, to solve the complete flow. It becomes computationally extensive for us to directly solve them. So we have, the earlier researchers have developed certain standards and certain procedures to overcome that issues and to model a turbulent flow as well in the computational simulation. All right, so let us come back to our guide over here, the Manual of ANSYS, which is the most important book when we are especially dealing with the ANSYS Fluent solver. Let us move to the next video and continue the discussion as to what is mentioned in this manual.